In this lesson, let's talk about substeps, and specifically, what are substeps, subframes, and timesteps? You might have heard some of these terms being thrown around, so let's figure them out right now because we're about to put them to good use. Suppose I had this section right here that's frame 1 to frame 2. Well, a time step, the way I like to think of it, is just really a chunk of time. So that whole step from 1 to 2 could be our time step in this case. It's just a block that occupies that time. Now, suppose we took this time step and we chopped it up into a bunch of smaller pieces. So in this case, now we have frame 1.25, 1.5, and 1.75. Well, these frames, these subframes, are what subframes are. And that's where the name comes from. Now, let's say we wanted to make little substeps now. So instead of a whole time step, let's make a substep. Well, I like to think of it as little blocks like this here as well. We have a block that exists between, let's say, 1 and 1.5, and then another block between 1.5 and 2. And these are substeps. So when you go to your DOP network node, you'll notice that we have the substeps parameter. And if it says 2 like this, the way to think about it is that you have 2 blocks of time that exist between 1 and 2, for example. So when this goes to cache out, it's going to cache out the subframe of 1.5. So it's going to go 1, 1.5, and then 2. Now, what is the point of substeps? Why are we talking about this? What's the use? Well, for one, substeps can improve the accuracy of our simulation. And that's oftentimes the main reason why you might add more substeps. But in addition to that, we can also use this subframe data to help us achieve certain effects. So let's start off by talking about this accuracy of a simulation first. Suppose I have a point, and suppose over time this point is supposed to land here on frame 2. So frame 1 we're right here, and on frame 2. And this little grayed out path is the path this particle is supposed to take because of all the different forces that are happening in the simulation. Now let's say that we have our pop solver and we have a substep set to 1. And let's also suppose that our pop solver is only allowed to think about things that happened on frame 1. If this was the case, it would not be able to think about all of those additional forces that influence the particle's path between frame 1 and frame 2. I'll bring this pen up here for a second to just show you. If we have, let's say, wind pushing up here and maybe pushing down here or something like that, from frame 1 to frame 2, with a substep of 1, it's not able to think about all of this information. And a lot of times, when it's not able to think about all of these in-between forces, you actually might end up with a particle in the incorrect spot. So maybe the particle should be here, but in fact, because the solver couldn't think about all the things that were happening in between, it ended up being over here. And that is how it would improve the accuracy of a simulation, just in general. Now, let's say that we added more substeps. So in this case, let's say we set our substeps to 3. We now have 3 sections of time. I like to think of it as 3 little blocks. And now we have frame 1, frame 1.33, frame 1.66, and 2. Now, as you can see, we're thinking about all of those, in between frames and all the forces that might affect the particle in between those frames, and we're getting more accurate because of that. Now, something that I should mention, though, is that we set our substeps to 3, but there is a drawback. Now, instead of the pop solver thinking about what happened from frame 1 to frame 2, it also has to think about frame 1.33 and 1.66. So a lot of times when you increase these substeps, you'll probably nearly double or triple or quadruple your simulation time. So it's something you have to be careful with. You don't want to just crank up your substeps, okay? Because again, it has to think about all of these things many times. And as you can imagine, if we increase this even more to, let's say, 6 substeps, we have even more accuracy. Okay, so what does that mean for us, and what can we do to help us create these cool little strand effects that we want to make, right? Well, if we want to make a strand, we know that we need to have 2 points to connect, right? And in this case, we could just use frame 1 and frame 2. We could just go like that. But again, we'll be left with that same problem where it's not going to give us the best looking result because it's not going to take all of that subframe information into account. So what we'll end up doing is we'll end up taking a few different subframes, we'll cache out these different subframes, and then we will use these points to connect and create our little strands. So that is what substeps are. And let's hop into Houdini and I'll show you how all that works.